Hi everyone, our today's topic is Floyd's algorithm, and this algorithm is used to determine the shortest route between any two points, any two nodes in the network. So our today's network is this with node 1, 2, 3 and 4, and we are going to develop the shortest route using the algorithm. So first of all, we will construct the initial matrix A naught. We'll construct the initial matrix A not using the network. 1 2 3 4 nodes and 1 2 3 4 nodes. Since the loops are not possible, so we will put 0, because going from 1 to 1 is not possible, going from 2 to 2 is not possible, similarly here and here. And in case of absence of any edge, in case of absence of any distance, we will put it as infinity. So going from 1 to 3 is directly not possible, but going from 1 to 2 is possible using 3 units. This is infinity and 7. Similarly, going from 2 to 1 is 8, 2 to 3 is 2, and 2 to 7 is infinity. Similarly, we will fill all the blank spaces like this. Right, and then we will construct the sequence matrix. Sequence matrix is not. That will tell us that no path is changed yet. This was sequence matrix. So now first of all, we have to find the shortest distances. Now here we consider the intermediate vertex as 1. Intermediate vertex as 1 means that all the paths we have to check if they are going through 1 or not, and if they are shorter or not. So for this, we will have the first matrix A1. This is 1 2 3 and 4, 1 2 3 and 4, like this. Okay, when we are keeping intermediate vertex 1, all the paths through 1 will remain unchanged. Means that first row and first column will remain unchanged, so we will write them as it is, like this, 2. And now we have to fill the blank spaces. Since these are 0, loops are not possible, so there are 1 2 3 4 5 and 6 values that we have to find. For this, that is A1 going from 2 to 3, we have to check if we pass through 1, means going from 2 to 1, and then 1 to 3, 2 to 1, and then from 1 to 3. A0. This is also A1. Alright, A0. Okay, so we will check our first matrix before this one, and we will see going from A0 2 to 3. In matrix A0, going from 2 to 3 was 2. Going from 2 to 3 was 2 distances, and 2 to 1 was 8, plus 1 to 3 was infinity, means 8 plus infinity, this is greater and this is still shorter, so we will keep it as 2 as it is, means this is not changed. Similarly, we will find this part 2 to 4. A0 2 to 4 is A0 2 to 1, passing through 1, and then A0 2 to 4. Okay, 2 to 4 in the first matrix A naught 2 to 4 was infinity, and here it is A naught 2 to 1. A naught 2 to 1 is 8 plus A naught 2 to 4 is infinity. Oops, sorry, this is 1. 1 to 4. 1 to 4 is 7. Means 8 plus 7 is 15, means infinity. This was infinity, and this means when we are going directly from 2 to 4, we don't have any you can say distance there, that is infinity. We don't have any path going directly from 2 to 4. But if we pass through 1, means if we go from 2 to 1 and then from 1 to 4, we will have 15, so we will put 15 here. Okay, and we just have to underline this. I'll just tell you later why we are underlining that. Similarly, we have to fill all the blank spaces with using this same formula, and then we will get 8, 5, infinity and 1. Okay, now just check what you have got. Underline this and this as well, because these are changed from the previous matrix. How many places are changed? This one is changed, this one is changed, and the rest of them are same except this one is also changed. So we will change the values here, means that the first column is same, so we will, for the sequence matrix S1, this is same, this same, and this is also same, and this is also same. Okay, 1 2 2 3 3 3 3 and 4. This is 4 and 4. This space, this and this is changed because we have kept the intermediate matrix 1, so we will write 1 here. Okay, means these parts are changed just because we are passing through 1. Okay, now this is our sequence matrix S1, and this is our matrix S2. Now we will keep the intermediate matrix as 2, and we will apply the same formula there. A2 is equals to, when we are keeping the intermediate matrix as 2, so the second row and the second column from this matrix will remain the same. Okay, 1 2 3 and 4. Second row and the second column will remain the same, means 3 0 8 and 5, 8 0 2 and 15, and this is all 0 as we know it. So we have to find 1 2 3 4 5 6 values there, and then we will construct this. After constructing this matrix, we will construct our sequence matrix 2, and then we will write the values here similarly. Okay, so all of you can see that we have constructed our matrix A2 and then sequence matrix from this matrix. Okay, now we will shift to this A3 matrix, and intermediate, we have kept the intermediate vertex as intermediate vertex S3, and then the fourth node is our last node, since we have only 4 nodes as an intermediate vertex as 4, means we have kept the fourth row and the fourth column same, and then we have find out all the values, and then we have constructed the sequence matrix S4 from this matrix A4. Okay, so now what we have to do, we have to find the shortest path. Now since this is our last matrix, we have to find the shortest path. Okay, we will consider this matrix as 4, that is very important to us. Alright, and if we have to find, suppose you are asked to find the shortest path from 1 to 3, you will see this matrix. This is 1 2 3 and 4, and 1 2 3 and 4. These are representing the nodes. This 1 2 3 and 4, and this 1 2 3 and 4 are representing the nodes, and you are asked to find the shortest path from 1 to 3. What will you do is, you will see node 1 and the node 3. Going from this node 1 to this node 3 is 2. So you have to go from 1 to 3. When you saw the matrix is 4, going from 1 to 2, 1 to 3, going from 1 to 3 is 2 is coming in between, so you have to go from 1 to 2 and then from 2 to 3. Okay, now you will see you have 1 to 2. 1 to 2 is 2, means you can go directly from 1 to 2, and then from 2 to 3, just see the matrix 2 to 3 is 3, means you can go directly from 2 to 3. Okay, so this means that if you have to go from node 1 to node 3, you have to go through 1 and then from 1 to 2 and then from 2 to 3. That will be your shortest path, and then you can see that the going from 1 to 3 directly is 5 units. This is 5 units. Okay, best of luck.